this lecture, we'll discuss some of the problems on efficiency. Say 400 volts DC shunt motor has an armature resistance of 0.4 ohms. So the supply voltage is 400 volts and the armature resistance is 0.4 ohms and the shunt field resistance is 100 ohms. Stray losses amount to, so what is meant by stray losses? Magnetic plus mechanical losses is called the stray losses. That should be equal to 2000 watts. What will be the efficiency when the motor takes 100 amperes? The motor takes 100 amperes. That means from the mains, if the input current is lowered by 40%, generally, okay, first of all, you should calculate the efficiency. After that, the current is lowered by 60%. If lowered by 40%, 40% means out of 100 minus 40%, but that should be equal to 60%. So 60 amperes. Okay, and find the new losses and efficiency. This is our problem. I am drawing DC shunt motor diagram. This is our armature. So I am giving a supply voltage V. This V is equal to 400 volts. The current drawn from the supply is line current, and the current flows through this armature is IA, and the current flows through shunt field winding is ISH, and the shunt field winding resistance is RSH. So we know that IA is equal to IL minus ISH. The IL value is 100. So the starting value of the current is 100 minus ISH. So ISH we can calculate like this: V divided by RSH. The V value is 400 divided by 100. That should be equal to 4 amperes. So 100 minus 4, that should be equal to 96 amperes. We know the stray losses. We have to calculate the armature copper loss. IA square into RA. So what is IA? The IA is 96 volts square into RA. What is the armature resistance? The armature resistance value is 0.4. Then I got it as 3686.4 watts. And this loss is called the armature copper loss. Armature copper loss. And another loss is also there. That is shunt field copper loss. It should be equal to ISH square into RSH. That is 4 volts square into 4 volts square into RSH. What is the RSH value is 100. So that should be equal to 1600 watts. Now what is the total losses? Total losses. We know that stray losses plus shunt field copper losses is constant losses. So stray losses, wow, what are the stray losses now? 2000 plus 1600 plus 3686.4. So the value of total losses is 7286.4 watts. So then what is the input power? So input power is equal to V into IL. That is called the IL1. This is IL1. The supply voltage is 400 and IL1 is 100 amperes. That should be equal to 400 into 100. That should be equal to 40,000 watts. So from the input power, if you subtract the total number of losses, then I get the output. So input power is equal to output power plus losses. Then output power is equal to input power minus losses. So then output power is equal to, what is the input power is 40,000 minus losses is 7286.4. That should be equal to 32,713 watts. Then we can calculate the efficiency at 100 amperes. Output power divided by input power into 100. So output power divided by input power into 100. So finally I got it as 32,713 divided by 40,000 into 100, 81.78 percentage. That is called the efficiency. The second case 2, the line current is reduced by 40%. That means IL2 is equal to 60 amperes. Again you can calculate IA1 or IA, that is called the IA, means this is IA1 is equal to, the IA2 is equal to IL2 minus ISH. So there is no change in the shunt current because we are not adding an external resistance. So this should be equal to 56 amperes. What is the armature copper loss? The armature copper loss is 56 square into 0.4. It is 1254.4 watts. Then finally total losses is equal to armature copper loss plus shunt field copper loss, armature copper loss plus shunt field copper loss plus stray losses. So these two are the constant losses. Why? Because it is a constant losses. Why? The shunt field current is constant. The stray losses is also constant. There is a mechanical losses plus magnetic losses is also constant. Only if the load varies, armature copper loss will be changes. So 1254.4 plus the shunt field copper loss, stray losses is like this 4854.4 watts. Then finally the motor input at this condition V into IL2. So supply voltage is 400 into 60, 24,000 watts. Now what is the motor output? The motor output is equal to motor input minus losses, that is 24,000 minus 4854.4, 19145.6 watts. Then calculate the efficiency value. Output power divided by input power into 100. So that should be equal to 19145.6 divided by 24,000 into 100. So finally I got it as 79.77 percentage. In overall problem, if you observe, the stray losses is constant and shunt field copper loss is also constant. Only one loss will be changes, that is called the armature copper loss. This armature copper loss is changes. Why? Because load is a variable, IA is a variable, IA square RA is also variable. So previously I got efficiency is 81.78 with full load current. If the line current is reduced by 40%, that means 60 amperes. For this problem, the efficiency is 79.77.